For the first time in history, humanity has captured images of an interstellar object from the surface of another planet. The subject of this unprecedented achievement is 3I Atlas, an enigmatic visitor from beyond our solar system that recently made a close approach to Mars. The photographs, faint and grainy yet profoundly meaningful, were not taken by a deep space observatory or a purpose-built mission, but by the Mars Perseverance rover, a robotic geologist whose cameras were never intended to observe the stars. On October 3rd, 3I Atlas passed within roughly 0.2 astronomical units of Mars, about 30 million kilometers. That distance, though vast by human standards, is close enough in cosmic terms to make Mars a prime vantage point. Anticipation among astronomers was high. Multiple space agencies, including NASA, the European Space Agency, China's CNSA, and the UAE's space program, had pledged to record the event using the satellites orbiting Mars. The Mars Reconnaissance Orbiter's HiRISE camera, famous for its astonishingly sharp images of the Martian surface, was expected to deliver unprecedented detail of this interstellar visitor. ESA's Mars Express and the other orbiters were also poised to make observations. But as days turned into weeks, not a single official image was released. Instead, the first confirmed visual evidence came from an unexpected source, the Mars Perseverance rover. Operating in Jezero Crater, Perseverance occasionally turns its cameras skyward for calibration and engineering checks. On October 3rd and 4th, it took several long-exposure shots of the Martian night sky. These images, publicly available through NASA's data feed, overlapped with the section of sky where 3I Atlas was predicted to be. Two independent amateur astronomers, Simon Schmov and the creator of Astronomy Live, downloaded the raw frames and began the arduous process of image stacking. By combining dozens of individual exposures, removing background noise, and aligning the star fields, they managed to extract a faint, diffuse patch of light that was unmistakably the interstellar object itself. This was not an easy discovery. Schmov's composite, built from 36 exposures on October 3rd, showed only a dim, cloudy blur. The next night, 40 more exposures were captured and processed by Astronomy Live, producing a cleaner image that revealed a central bright spot surrounded by a pale green coma, a glowing envelope of gas and dust sublimated from the object's surface. Against all odds, these images became the first interstellar observation ever made from another planet. The discovery carries both scientific and symbolic weight. Scientifically, it confirms that 3I Atlas was where its calculated orbit predicted it would be, strengthening confidence in the accuracy of prior measurements. Symbolically, it demonstrates the extraordinary power of public data and collaboration. Two citizens working with free access imagery from a rover millions of kilometers away achieved what the world's largest space agencies had not yet revealed. The absence of official imagery, however, has puzzled many. Normally, NASA and ESA release raw images from Mars orbiters after a short delay, but in this case, nothing appeared. NASA has not commented, and ESA has remained similarly silent. The most likely explanation lies in bureaucratic and technical hurdles. Processing interplanetary imaging data takes time, especially amid the current U.S. government shutdown, which has slowed operations across multiple federal agencies, including NASA. Yet the delay has also fueled speculation online, with some suggesting more dramatic reasons for the data blackout. In reality, the explanation is probably mundane, but the silence has nevertheless deepened the mystery surrounding 3I Atlas. As of now, the object has disappeared from view. After its Mars flyby, 3I Atlas moved into a region of the sky too close to the Sun for Earth-based telescopes to observe. On October 21st, it entered Superior Conjunction, passing directly behind the Sun from our perspective. For the next 6 weeks, it will remain hidden in the Sun's glare, completely invisible to observatories on Earth and even to space telescopes like Hubble and James Webb. Astronomers expect that it will become visible again in early December, assuming it continues along its projected path. 3I Atlas is most likely a comet originating from outside our solar system, following a hyperbolic trajectory that will eventually carry it back into interstellar space. Its spectrum and brightness variations suggest an unusual composition, perhaps containing exotic ices or minerals formed around another star. Yet not everyone agrees that it is merely a comet. Some theorists, recalling the controversies around the first interstellar object, Oumuamua in 2017, argue that a small but non-zero chance remains that 3I Atlas is artificial, a piece of alien technology, perhaps a probe or derelict craft. That possibility is remote, but not entirely dismissible. From a scientific preparedness standpoint, even that faint possibility underscores the importance of monitoring such visitors carefully. At present, humanity stands in a peculiar kind of darkness, not the absence of light, but the absence of sight. We are, for all our scientific sophistication, effectively blind. The only available imagery of the interstellar object known as 3I Atlas comes not from the gleaming observatories that circle Earth or the powerful telescopes peering into deep space, but from the modest cameras of a single rover operating alone on the dusty surface of Mars. Those cameras, designed to study rocks and sediment, were never meant to capture distant celestial phenomena. Yet in an irony almost poetic, they have become the sole eyes through which we glimpse this cosmic wanderer. High above the Martian plains, the Mars Reconnaissance Orbiter carries the HiRISE camera, one of the most powerful imaging instruments ever sent beyond Earth. In theory, it could have given us stunningly detailed data on 3I Atlas, resolving the shape, color, and even the coma that may surround it. But so far, nothing has been shared. The data, if it exists, remains locked away in the servers of space agencies. No one outside of those institutions knows what HiRISE saw, if it saw anything at all. If 3I Atlas has changed in brightness, fractured, or begun to outgas more intensely as it draws closer to the sun, we would have no way of knowing. That uncertainty gnaws at scientists and enthusiasts alike. For now, the object has slipped into the blinding radiance of the sun. It will not emerge until late in the year, when it reappears from behind the solar glare and once again becomes visible to our instruments. Perhaps by December, the Hubble Space Telescope and its younger sibling, the James Webb, will be able to train their mirrors on it again. Perhaps, too, the European Space Agency's JUICE mission, currently traveling through the outer solar system, will capture a faint, distant glimpse in November. Yet even if it does, those images will likely take weeks, even months, to process, verify, and release. By then, the moment of its closest passage, and whatever secrets it might have revealed, will be long gone. This forced period of darkness has stirred a deeper conversation among scientists, one that goes beyond this single object. It has exposed a sobering truth. Despite all our telescopes, orbiters, and satellites, humanity's ability to monitor the cosmos remains profoundly limited. Our instruments may stretch across planets and into orbit, but they all share the same geometric blind spot: the sun itself. When an object moves into conjunction, passing behind that overwhelming glare, we lose it completely. It is a vulnerability that many have warned about for years. Astronomers and engineers alike have argued for deploying deep space observatories in other orbits, perhaps at Venus's distance or positioned at the far side of Mars, so that when the sun blinds one side of the solar system, another set of eyes can continue watching. In principle, the technology exists. What's missing is coordination, funding, and will. The mystery of 3I Atlas has made this deficiency uncomfortably clear. A visitor from another star has entered our system, and we cannot see it. In the vacuum of reliable data, imagination rushes in to fill the void. Rumors have proliferated, interpretations have diverged, and myths have begun to take root. One image in particular ignited a storm across social media. A long-exposure photograph from Perseverance showing a bright, elongated streak slashing across the Martian sky. To the untrained eye, it looked eerily like a glowing cylinder, unmistakably artificial, impossibly precise. Within hours, posts and videos proclaimed it to be the first definitive image of 3I Atlas, an alien craft caught on accident on camera. The excitement was electric, and the fear was palpable. But the truth, as is often the case in science, was simpler and more elegant. The streak wasn't an alien visitor. It was Phobos,
one of Mars's two small moons. During the long exposure, Mars rotated slightly and Phobos moved along its orbit, creating the illusion of a bright, elongated shape in motion. Perseverance's camera, in its patient recording of the night sky, had captured the moon's path as a luminous line. Its shape had nothing to do with 3I Atlas. It was merely the dance of a moon and a planet recorded through time. Yet there is an uncanny poetry in that coincidence. The name Phobos comes from the Greek word for fear, and in this moment it lived up to its name. The image of Phobos became the symbol of humanity's unease, our instinct to project mystery and meaning onto the unknown.
Even prominent scientists were not immune to the confusion. Astrophysicist Avi Loeb, known for his bold speculations about interstellar objects, published an analysis of the so-called image of 3I Atlas, interpreting it as potential evidence of an artificial origin. Only at the end of his article did he clarify that the identification was unconfirmed and that NASA's documentation made no explicit mention of 3I Atlas in relation to the photo. But by then, the spark had already caught. Many readers, captivated by the idea of alien technology, never reached the cautious footnote at the bottom. In an era where speculation spreads faster than verification, nuance often arrives too late. Soon after, another piece of footage surfaced online, a clip showing a luminous object streaking across the Martian sky. Again, it was hailed as the interstellar traveler in motion. But careful analysis by astronomers and data specialists quickly debunked the claim. The object moved far too fast across Perseverance's field of view. At 0.2 astronomical units away, 3I Atlas would have appeared almost stationary, inching across the sky only over the course of hours, not seconds. The streak, most likely, was something local, perhaps a small asteroid passing close to Mars, a meteor, or even a high-energy cosmic ray striking the rover's image sensor. These episodes revealed something more profound than a case of mistaken identity. They demonstrated the human need to make sense of the unknown. When the official record is silent, when data is missing, imagination becomes the default tool. In that vacuum, myth and meaning take shape. The cosmos becomes not just a physical space, but a psychological mirror reflecting our hopes, our fears, and our longing for connection. And yet, amid all the noise, the genuine discovery remains extraordinary. The faint smudge extracted from Perseverance's night sky images is a historic first, an interstellar object seen not from Earth but from the surface of another planet. It wasn't the result of an accident or a lucky streak, but of deliberate curiosity and human persistence. Two amateur scientists using publicly available data achieved what no official mission had yet shared. They reached across the gulf of space with software and ingenuity, and from the raw data of a rover's skywatch, they uncovered a glimpse of a visitor from another sun. What 3I Atlas actually is remains an open question. Based on every observation we have so far, it behaves like a comet, a body composed of volatile ices and dust, vaporizing as it approaches the sun and forming a coma, that ethereal shroud of glowing gas that surrounds its nucleus. Its subtle green tint, visible in the processed images, likely comes from diatomic carbon, a molecule common in comets which glows green when excited by sunlight. Its orbit, sharply hyperbolic, confirms its origin beyond our solar system. It came from the stars and will return to them, never to loop back again. In that sense, 3I Atlas is a messenger, a fragment of another system, a time capsule from elsewhere in the galaxy. Every interstellar object that passes through our solar system carries within it a record of the environment in which it was born. The atoms frozen in its ice, the minerals embedded in its dust, all whisper of another sun, another history, another dawn of planetary formation. To glimpse one, even briefly, is to touch the edges of the cosmic story that shaped not only our world, but countless others. The significance of this moment extends far beyond astronomy. It reveals something essential about us, about humanity's desire to understand, to explore, to see beyond the horizon of what is known. Despite our probes, our orbiters, and our telescopes, we remain a species limited by vantage point. When an object like 3I Atlas passes behind the sun, we lose sight entirely. For weeks or months at a time, the universe continues without us, unseen.
For a civilization that dreams of reaching other worlds, that limitation is both humbling and motivating. If 3I Atlas is, as most believe, a comet, then it is a silent traveler carrying the chemistry of a distant star system, ancient ice and dust formed before Earth itself existed. But if it is something else, something we have not yet conceived, then it stands as a reminder that the universe is still filled with surprises. The distinction hardly matters in the end. What matters is what it tells us about our readiness, or lack thereof, to observe and understand.
This event has reignited discussions about our preparedness as a species to detect and study objects entering our solar system. Just as meteor detection networks watch the skies for potential impactors, interstellar monitoring requires a new generation of instruments. Telescopes placed not just around Earth, but distributed throughout the inner solar system. A constellation of deep space observatories, positioned at multiple vantage points, could keep watch even when the sun blinds one side of the system. Such a network would not only protect us, but deepen our understanding of cosmic visitors, like this one. For now, though, all we can do is wait. The next few months will unfold as a long and uneasy silence. Scientists will model the trajectory of 3I Atlas as it loops around the sun, predicting its position and estimating how much material it might lose during perihelion, its closest approach. If it survives the heat and gravitational stresses intact, it should reappear in December, emerging once again into the twilight sky. When that happens, telescopes across Earth and in orbit will pivot toward it, eager for another look. There is even a small possibility that the object could appear on images from the SOHO spacecraft C3 coronagraph, which monitors solar activity. The instrument, designed to block the sun's blinding light and capture the surrounding corona, occasionally records bright planets as they pass nearby. If 3I Atlas is large or reflective enough, it might show up as a faint point moving across the coronagraph's field. Such a detection would be a welcome gift, a chance to keep eyes on the traveler even during conjunction. But if it's too dim, we will remain blind until it clears the sun's glare. The Perseverance rover, our solitary witness on Mars, continues its primary mission, collecting rock samples, scanning for signs of ancient water, and studying the weathered plains of Jezero Crater. Every few nights, it still looks to the sky, its cameras quietly recording. Among its archive of Martian sunsets and starlit skies, a few frames now carry something no other image has captured, a ghostly blur that marks the path of an interstellar traveler. Those images are not beautiful in any conventional sense. They are noisy, grainy, and obscure. Yet their meaning transcends aesthetics. They mark the first time in human history that an object born around another star was photographed from the surface of a planet not our own. They are a symbol of how far we have come and how far we still have to go. The story of 3I Atlas is a story of curiosity and humility. It is about the limits of our technology and the boundlessness of our desire to understand. It is about the power of open data, that two individuals, far from any space agency, could uncover a piece of cosmic history using information freely shared with the world. And it is about perspective, the recognition that even with all our advancements, we remain a young species, still learning to see. Whether 3I Atlas proves to be a typical comet, a peculiar fragment, or something utterly strange, its visit has already left an imprint. It has reminded us that we are part of a larger system, one where stars exchange matter, where dust and ice travel across light years, and where, every so often, the universe sends us a visitor to remind us that we are not alone in its motion. For a brief, remarkable moment, Earth and Mars shared a common view of a traveler from another world. From the rocky plains of Jezero Crater to the observatories of Earth, humanity looked upward together, squinting into the vast dark, trying to see and to understand what had come to visit. The images may be faint, the details uncertain, but the message is unmistakable. The cosmos is alive, and we are finally learning how to listen. As it drifts now behind the blinding light of the sun, invisible and silent, 3I Atlas carries with it questions that no photograph, no dataset, and no theory can yet answer. When it emerges again from the solar glare, telescopes will turn toward it, instruments will hum, and once more we will try to learn from a visitor that comes to us across the dark between the stars.
Until then, the faint image captured by Perseverance, a small, blurry mark against the Martian sky, stands as a reminder of what is possible when curiosity meets patience and when the human spirit looks outward into the vast unknown.